Hey everyone, really excited to be here. Thank you for you who can make it. Today I'm going to talk about how you can automate the process of model retraining in production and and we will introduce you a framework how it can be done. So a little bit about myself. I'm Or, 35 years old, lives in Tel Aviv, and over the past 8 years, I've seen both sides of machine learning, both as a data scientist and as an ML engineer. And I had the chance to experience all the difficulties, the research ones, and what does it mean to take model to production and make it work on a successful way. In the last 3 years, I'm the chief architect at Superwise AI, and together we are building the solution that I wish I had years ago as my years as a data scientist. So the marketing slide about Superwise. So we are a machine learning observability platform. We actually build a solution for data science teams in order them to scale their AI activities, machine learning activities, and make them focus on the things that are really matter. Build the new models and grow their impact in the business, while they know that someone is there watching and taking care of their models in production. So I'm pretty sure that all of you here already know that we are in an amazing era, the rise of MLOps. We can see new tools every day with new companies which have really good ideas, and I'm pretty sure that you already know that things in production is changing. It could be that the business has business evaluation. It could be ETL or data issues. It could be like concept drift or data drift and so on. I'm pretty sure you already heard about those terms in the past. And I'm pretty sure that you all know that the minute you deploy your model to production, then its performance starts to degrade. It becomes less and less good once it's running and run into some real use cases. But the things that are less talked about is what can be done next. Once we detect these performance issues, once we get some incident alert that, I don't know, there are concept drift, there is data drift, what can be done after that? So the way I see it, companies today does not have a clear strategy of how to handle these alerts. Who is responsible for the model in production? What should be done once we detect a data drift or a concept drift? Who is the one that's responsible to fix it? Who need to test it once it's fixed? All the processes behind it are not well defined yet, if there are some any at all. So yes, this is a model retraining talk, but before, I just want to emphasize that retraining is not always the answer. There can be other stuff that can be done before model retraining. It could be that we have data issue, and we need to fix the ETL. It could be that we just need to adjust the model threshold, or we can just recalibrate the model. We need to know what exactly happened in order to give the appropriate solution. Model retraining is one of them, but doing model retraining as an afterthought can create more damage than good. So we need to pay attention when we decided that the things that need to be done is the model retraining. So yes, this is a lecture about model retraining. And for me, as one that already 3 years in the MLOps ecosystem, for me, MLOps is all about creating an automation of the infrastructure of the processes that models have in production. And one of the key factors is actually how we know when it's the time to retrain the model, what will be the best strategy for it. And as I can see from customers that we have, most of cases, we have some ad hoc solution, like, okay, let's try to retrain the model. or in more other things, or more other customers have some kind of an automation in place, but very naive one that, as I said earlier, can create even damage. So today I'm going to talk about what is the questions that need to be asked once we decided that we want to retrain the model and create an automated process for it. The main idea here is how to automate it. Once we will create an automation in place, we can really scale our models in production. Without it, and by doing a lot of manual work, our data scientists will need to sit and keep their models. So Google introduced a new term, I think it was 2 years ago, in some blog post they published. Very good one, I very recommend on it. And they talked about continuous retraining. Like we have a CI/CD, we also have a new term here, continuous training, CT. And as they defined it, continuous trainings seek to automatically and continuously retrain the model to adapt the changes that occur in our data set. And in this blog, Google described it more, and they took the engineering point of view of it. How we can close the loop from serving to the orchestration stack and trigger the new pipeline once we detect such thing. So today I want to extend it a little bit and not just talk about the engineering part of it, but I want to talk about the questions, how it could be done, the things that need to take into account once we decided that we want to retrain our model. So this framework contains mainly 3 main steps. The first one is when should the model be retrained? The second one is which data should be used as a training set? And the third one is what should be retrained, which part of the data pipeline? And let's start with the most basic and I think the most common question, when the model should be retrained. So actually we are trying to find the trigger from the model monitoring that will start a new pipeline that in the end will create a new model instance that will deploy to production. We can think about 3 main approaches here. The first one is a periodic trigger. The second one is a performance-based trigger. And the third one is based on changes in the data. So let's start with the periodic trigger. I think this is the most naive and straightforward approach. We will retrain the model on a fixed window size. Let's say, for example, every 3 months. It could be time-based, or it could be volume-based. For example, on each new 10,000 feedbacks that will arrive. In cases that will have a lot of seasonality, inherent seasonality in the flow, we might use the time-based approach. And if we have an inconsistent feedback collection and we don't know when we will get enough data for our next retraining, then we will use the volume-based approach. So as you can probably understand, this approach is very easy to implement. We just need to set a cron job that runs once in X months, and we'll start the new pipeline again. Finding this window size can be tricky. If we will train the model too often, like we will select very narrow time frame, it could be costly and inefficient. Each retraining is taking from us computing resources and also our data science team's attention. They will need to oversee the process and to make sure that the new model is work well as they expected. And if we will select too long intervals, like the time between each retraining will be too long, we may fail to adapt changes in the data. It can be too late. But the main drawback of this approach is that in reality, things are not deterministic. We cannot expect when the performance will drop. So in domains where things are more predictable, yes, this is a good approach. But when things are more dynamic, it's really hard to tell when the performance will drop. Here you can see, for example, that the drop started just after a new retraining. So until we will next to the next periodic retraining, it could be too late and the performance will already damaged. The second approach, which is more data-driven oriented, is to retrain the model only once we see a performance degradation. So the big advantage here is that the performance is a data-driven approach. Means we are looking here on the bottom line, the model performance. And like the old engineering practice, if it ain't broken, don't fix it. There is no point to retrain the model if everything works as expected. But inside this approach, there are also drawbacks. So let's take, for example, a use case, a loan approval use case, when a model predicts if we want to approve a loan, and until we get the feedback if the loan was okay or not a good decision or not a good decision, it could take time. It could take 6 months or even more. So actually, the point that we detect the performance degradation, we need to edit also the feedback delay. This is the real time that we understand that the performance degradation has started, and it could take months. And it could be too late for us to start and retrain the model in this point. The damage already been done. This approach can be useful in cases like real-time bidding and so on, when we have a very high volume of data and we can calculate the performance metric just in the seconds after we gave the predictions. But I think in most cases, this is not the reality. We need to wait for the feedback. Also, we need to take into consideration the assumption that we have feedback in place, because in some cases, like unsupervised learning, we don't even have feedback. We don't have a way to calculate those performance metrics. We need to think about proxy measurement or something like that. So this is the performance-based approach. And the last one about when to retrain our model is approach that is more driven by changes in the data. What does it mean? Machine learning models are built on the assumption that the data that was in the training set is the data that you want to see in production. It should be similar as possible to the data in the training set. And once it's okay, it's the same data, we are supposed to be okay. But if we take, for example, an intent scoring model, which tries to predict whether a new user that will come to our website will convert or not, and we build this model on, I don't know, European users, and then the marketing started a new campaign, and some American customers will start to arrive the model, and the model have not seen them before. So it will be it will be not optimal. It didn't see them yet, so maybe the performance will not degrade, but they are not optimal as possible. So we need, this is not, I know, just a second. I want to emphasize what not optimal is. It does not mean that the model performance will be degraded. It means that they can be even better. The main advantage of this strategic is that it does not depend on the feedback. Means it's available immediately. Just after we get the prediction, we can calculate this metric and see if something went wrong, if we get some new data that was not part of the training data set. This is the main advantage here. So when to retrain the model? When is the right time to retrain the model? There is no one solution fits all. You need to ask yourself a few different questions. How dynamic is my domain? if it's like an image recognition, or it's a more like dynamic environment. What is the volume of the data? The feedback availability and its delay, if we have long delays or very short ones, and the production observability level. In order to track those data changes, we need very good observability on our data in production. The second question in this framework is, which data should be used as a training set? So actually now we are looking about the part that we extract the data from a feature store or database and so on, and this data will be the base for the model retraining. And we want to find the data that looks as much as possible to the production data. Here I will review also 3 different approaches. Let's start with the most naive and straightforward one. It is the fixed window size. Basically, we will select a constant number, let's say 6 months, which will be the training data set. So again, this approach is very easy to implement. Just use a constant param. But you need to pay attention to select the right window size. Because if we will set it to be too wide, we might miss new trends. So for example, if I want to train my model today, and I will take the 2 last years of data that contains all the COVID and lockdown stuff and so on, I might put some unupdated data in my training set that does not necessarily reflect how data is looking today in production. And if I will select a too narrow window size, it might be overfitted to noisy days. Let's say, for example, we have like a Christmas or Election Day or Black Friday, and they are part of the training set, and the training set is very small, then the model might think that these are the normal behavior and will overfit to them instead of like ignoring them. A more data-driven way to choose this parameter, the window size, is like treat it like another hyperparameter that we can learn and optimize during the research phase. Sorry. This approach, as you can see here, I did a little experiment. I built 3 different models, each one of them with a different window size of training time period. One with 5 weeks, one with 3 weeks, and 1 week. And in the end, I evaluate each one of the models on a training set and get this model performance. Later on, I select the model that gave me the highest AUC score. So this is more a data-driven approach. We can automate it, like to be part of our retraining pipeline, but it's more complex. Let's say, for example, on each new model retraining, we will train 3 models. Each one of them will have different window size. It will take more time. It will take more computing resource, but in the end, it's based on the model performance. So it can help us to find the right param. Okay. The last approach to select the best training set is built on the assumption that we want to find the data that is the most similar to the data that's running currently in production. But what does it mean, similar as possible? How I can measure this similarity? It's a tricky question. So in order to do that, it's going to be a little bit complex, but I put my data science glasses back on, and I try to build a model that actually tries to separate between 2 dates. The label is the date. The feature is the same feature vector, and my model tried to predict which date the data came from. The intuition behind it is that if the model will be able to distinguish between those 2 days, they probably have different distributions. They look very different. And if the model will not be able to separate between them and think they are very look alike, probably they have the same distributions. Okay, makes sense? So I use the ROC-AUC of the model in order to determine how much the model be able to separate between those 2 days. And again, if we have a good model, which means we have a model that be able to separate between those 2 days, means that those days are looks very different, and we will get a high AUC score. Then I created the following distance metric. For each pairs of date, each cell here in the matrix represent the AUC score of combining 2 different dates. And I repeat it over and over again for every combination of 2 different dates. And in the end, I add a little bit coloring to it to make it be more nicer. I know it can be overwhelming, but you can think about like that. The more red the cell is, the higher the drift. Means the days look very different. And the lower cells, the low drift means that the days looks quite the same. And from here we can take few insights. The first insight is that we can see this December month, the data look very different from the rest of the data. So then we can drill down and try to understand what happened in December. Maybe it was a data issue. Maybe the marketing started a new campaign. Maybe it's just a glitch in the data. But we can decide whether to put it as part of the training set, or we can exclude it, not let the model knows that, the model ignore it. It should not train and try to generalize on this noisy data. We can also find here some recurrent series of days. You can see 5 days and then 2 days with different color, and then 5 days and 2 different days. These are actually weekdays and weekends. And this raises the question whether maybe it should be a good idea to separate it into 2 models, one model for the weekends and one model for the weekends. Like I said before, retraining is not always the solution. And in this case, model splitting might be the case. But this is just other insight. I will skip this one. So what data to use? We want to use data that is similar as possible to the production data. Another insight here is that putting the training data on a timeline enables us to understand and get some more insights in how the data looks like, and to find days that are very different and to exclude them from our training set. The third thing is the most recent data does not mean necessarily the most relevant data. It could be data issues in it that we want to clean up. And the fourth point is that it's required an high visibility on the production data. We want to understand how production data looks like. The last question is, what should be retrained? Which part of the pipeline? So we are talking about this area, the one that we build during the research phase. The most naive approach here is just take some new data, refit the model, and get some new model instance instead. But if we can think about it, maybe when the data scientist done his research, it tried few different models with few different hyperparams and different data preparations. Why don't we do it again for each retraining? We can automate the data scientist research work and try to do it for each new model retraining. some kind of a semi-auto ML. This way will enable us to build the most robust and the model that will adjust to the dynamic of the environment and the new data that will arrive. Obviously, it can create some complexity in the code. The pipeline should be built in a manner that will try to find the right parameters, different models, and so on. And it will add a lot of complexity and a lot of code to the data pipeline, which in the end can cause a lot of bugs and edge cases that need to be tested. So it's a good idea to automate the process, but it creates a lot of complexity. So let's start to sum things up. We talked about 3 main questions that we need to ask ourselves once we want to build a continuous retraining strategy. The first one is when it's the right time to retrain the model. We talked about periodic retraining, performance-based retraining, and driven by changes in the data. The second question was which data to use as a training set. We talked about a dynamic or a fixed size, window size approach, and we talked about dynamic data selection. The third question was what part of the data pipeline should be part of the retraining? Just an hyperparameter optimization, model selection, or new feature selection even. Each one of those possibilities requires different complexity level and different observability levels. So let's try to think how we can automate this strategy as part of our production pipeline. So first step is to put some monitoring policies in place. Let's look for a performance degradation or a training serving skew. Sorry. Once we detect such events, we can get a trigger. This trigger could be like webhook that will start a new model retraining all over again. In the data extraction phase, we can select insights directly from production to understand which data is the most relevant for our model. We will try to look for the data that looks similar as possible to the production data, and to extract it from our DB or feature store. And the next phase is written the code in a manner that will enable us to try to find few different configurations of models of hyperparameter that in the end will give us the best model that is most robust and adjust to the dynamic of the data. Once deployed, I will recommend you to deploy it as an A/B test or in shadow mode in order to make sure that this automation works okay and not like create like not updated model. So the main takeaways that I want you to take from this talk: retraining is not always the solution. You need to understand what really happened in production, and then you should choose. If it's retraining, okay, let's have a strategy in place, but it could be other things as well. Build a continuous training strategy is necessary, is required, it's mandatory if we want to scale our machine learning activities. The third thing is like building a continuous training strategy should be fit to your use case. We need to ask ourselves those questions that you saw before in order to build the right strategy. And the last thing is, once we define the strategy that are more suitable for our use case, we need to monitoring it and make sure that we set the right policies in place. That's it. So if you have any questions, feel free. We also have a community edition to supervise. You can just sign up and get your free models monitored.
Hi there, thanks for the talk. Just a quick question on dynamically selecting the window size.
Yeah.
And if I understood it correctly, I think you mentioned we're going to use a different model that predicts which day does the data come from. And I just want to ask whether there's kind of a small recursive issue here where, we have a second model, and now I need to worry about continuously training that model, and that will need another model. So
yes, you should build different models. But let's say, for example, you have monitoring solution in place. This metric, let's say in Superwise, is coming out of the box. You have the model drift on a daily basis we are doing it for you. Like, you don't need to build the models by yourself.
So there is another model under the hood, I presume.
Yeah.
And what retrains that model? Like, does it not need retraining?
Yes. This model have a different point of view. It does not look for to try to predict the same label. It tries to predict the day, which is much more simpler than trying to find a fraud or something like that.
Yeah, I see what you mean. So it's a simpler model. Yeah. So that makes sense. Thank you.
It's just, by the way, there are many other ways to measure the drift between different 2 days. This is just an example. It could be more like a statistical measure, like a KL divergence between each features and so on.
Makes sense. Thanks.
Thanks.
Hey, thank you so much for the talk. I had a question about the data-driven approach. So you've talked about choosing the window during retraining, but I had a question about how do you pick a trigger? Like, we have some snapshot of the training data, and we want to compare the difference between training and production. How do you choose which window of production data to compare? Like, we can have 1,000 samples of production data. We could compare all the training data with only 30 samples, the most recent one, or a larger window. How do you choose the window to actually trigger the potential retraining based on the data?
So we are talking about this approach, right?
Mm-hmm. Yeah.
So basically, also for this approach, the training, the validation set should be as similar as the latest data from production. But yes, it should be like similar to production as we saw earlier. So the data should be like the most similar as possible to the production data. We need to pay attention about, like, this is a classical offline validation, like we do in the research phase, but the goal is to find this right parameter that will give us the best model performance.
Okay. But if we are talking about data and we don't have the feedback yet, so we don't have the labels to compare.
This solution will not be the right approach if you don't have feedback on the latest data. You should think about different approach.
Okay, thank you.
There are pros and cons for each one of the approaches. Yes.
Thanks.
Hi, thank you for the presentation, really inspirational. And my quick question is, would you please share your thoughts on the data reshaping and adding new data to the to do retesting or retraining?
Sorry, can you repeat, please?
In terms of adding the new data to do the data retraining, what would be the difference if we use data reshaping? So say we don't add new data, but use original data set, but reshape the data. So say, for example, if it's a time series data, you have column and in terms of the original one, and then you just switch the column and switch the column.
Oh, I see, I understand.
Yeah.
So basically, again, the main assumption for any machine learning model is the training data should be as similar as possible to the production data. So if we reshuffle the data and do some kind of a data augmentation, we still need to make sure that is similar and have the same distribution to the production data in order for the model to work well.
So this is at the model evaluation, performance evaluation purpose, but in terms of retraining, how would you think it is durable or no? I mean, if we don't have in real world, if we don't have access to the too much data as additional new data to inject into the current model to do retraining, so what we should do? are we able to reshaping what we have and do it or no?
So I will be happy to take it offline and to try to understand the specific use case in more detail.
Okay. I don't have a particular use case for now, but actually I'm collecting the data on behalf of my company currently, but it's really fluctuating, the numbers, because in the real world, the business situation change every day. So it's not really can tell any specific thing we are looking for. But yeah, so data is very important. And this is what I understand. But thank you very much.
Okay, thank you.
Yeah, just a small follow-up on my first question. I mean, something you didn't cover. Maybe I'm curious about your opinion. Kind of feature importance and its role in this data drift detection. So if we use, you mentioned there's a model under the hood, or you can use a statistical technique. That won't take feature importance into account, right? And that really has a big impact. Like even if the data changes, yeah, feature importance is a factor. So just curious what you think.
So you can use the feature importance to understand exactly like the magnitude of each feature in the overall drift. So the more the feature is important to the model and the high drift that it has, it might affect on the performance.
Yeah, but then you can't just use a generic model to detect data drift is what I'm saying. Like you need something needs to understand the model itself to be able to detect data drift for that model, as opposed to like a generic model or a statistical approach.
I see what you mean. So again, if you will use a generic model, it's just trying to separate between those days. So each new model, it can have a different feature importance. We can think about a way like to take an average importance across all models to understand what really affects this specific separation.
Hi. So suppose you don't have data drift, but over time technology also changes. Suppose we have a better technology. So we will have to train the model again, right? So as to improve so can this be also automated, or it's a manual decision that the teams take?
So it depends. It really depends. If you dig in and try to understand why the performance is degraded, and you see, let's say, for example, I think we have a slide for it. So here, for example, we understand that there is like different data behavior in this specific thing. And if we will drill down and see that because we have data issues, like missing values in one of our important features, so it might be the case that you don't need to retrain anything. You just need to fix the data pipeline. Or if, for example, you can see that the model decision was drifted, maybe you just need to recalibrate or change the threshold. You don't need to retrain the model. It's really depends, and you need to dig down and understand what's really happened behind the scenes.
Thank you.
Hello, thank you so much for your talk. And then it's just a funny question for brainstorming. So for the approaches that you just mentioned, it's like selecting the data, selecting the time frame, and selecting which part of the model to do the retraining. So I'm just thinking, all of these strategies, it will result in a sharp change on the model. So is there any way that we can make it a gradual changes or gradual improvement on the model instead of having a sharp change on the model? That's all.
So
do you understand the question?
Not so much.
So it's for the retraining that part, we will be changing some part of the model, right? So the performance of the model will be changed sharply. There's a cut on the performance of the model. So is there any way that we can do the graduate training instead of having a sharp cut?
Yeah. So basically, the data selection can be dynamic. The most recent data does not necessarily means the most relevant data for the training. It can be that the data that you should use is like 1 year ago or something like that. If it looks similar like to the production data, it might be a good use case. Hope it.
I think she's asking about something. One of the graphs you showed that showed like a sudden spike in his training, right? So she's asking if it's possible to have like a.
This one?
No, the other one. Yeah. So if it's possible to have something like a gradual retraining instead of like a sudden spike.
So this is like showing that suddenly there was change in the data, that suddenly in specific point of time, all the data started to look very different from the training data set.
Here in this approach, you are trying to identify the drift between your current data, your production data, and the training data. Mm-hmm. And if there is a drift, you would retrain or see what you can do. Mm-hmm. But sometimes you can have a drift in the data, but it doesn't affect your model performance.
Yeah, exactly.
So maybe we could explore like a mix of those approach, like if your model performance is going down and you have a drift, then you retrain or something.
Yeah, it's a really good question. So it's the combine between the two can give you the full coverage. This one, this approach does not necessarily mean that the performance is dropped, but you can agree with me that it might be that the model is not optimal. If we will train a new model that sees this new data already, it might give us even better performance. So we can look about two things here. When we saw model degradation, like a performance degradation, or looking for a data drift. Both of them can trigger a new pipeline and give us the full coverage.
Thank you.
No problem.
Thank you for the great presentation. So I have a question about adding the new data for retraining. So if the model I use is a supervised machine learning algorithm, but the new data I have is labeled by the algorithm in production. So in this case, how could I utilize this new data without adding any bias into the model?
So it's a really good question also. Again, even you have labeled the data on an ongoing way, you still need to make sure that the data in production is very similar to the data, like the labels are good. The labeling job is like, how do you label the data in production? Let's say it like that. You have like a human manually?
In production, it's by model. So for the new data, we label it by the model in production. But before the model was developed, we label it by human.
Okay.
Like on the writer.
Yes, you need to make sure that the labels are okay. Other than that, the garbage in, garbage out type of thing. Like if we will train the model with not such a good labels, it will affect its way to generalize the real use cases.
Mm-hmm. Thank you so much.
For the dynamic data choosing, was it one single model that was multi-class, or did you have
No, so
models?
For each cell in the distance metric, I trained a new model. Each one of them is a new model that tries to separate between two different days.
So it's just trained on all the data for those 2 days?
Yeah.
So for day Monday and Tuesday, for instance?
I combined together two pieces of data, one for the first date and one for the second date, add the label to it, and the classifier is just trying to separate between those days and to predict which date the data came from.
Gotcha.
So I repeat this process all over again for each combination of two different days.
And then the heat map was the AUC?
Yeah, and the heat map contained the AUC as like a approximation of the drift. And this metric, the heat map, it's actually the drift for each different 2 days.
Gotcha.
Okay, thank you, Dr. Isheri, once again.